Yeah, so welcome everyone. So this will be the presentation on the new block model manager as part of the MinePlan portfolio. So I'm Vern Weiss. I'm the product manager for MinePlan 3D. I've been around at Hexagon for about 12 years. I started off in the support and services team, and now I'm responsible for MinePlan 3D. So all your CAD needs, all the underlying data structure needs, just come see me and I'll try to get it into the product. So this will be a presentation introducing the new block model manager. Brand new product, but it'll give you it'll show you like an indication of the direction that we're taking the company and the product in terms of architecture. So I'll just kick it off with a video, and hopefully you guys have seen this video already through our social media channels. Yeah, awesome. So just starting off, back to the basics. So what is a block model? So any geologists in the room? Yeah, do you want to volunteer yourself to give us? Yeah. Any engineers in the room? Yeah. Who wants to volunteer to give an explanation of what a block model is? Yeah, so for us, I think we've tried to define it, and it's a 3D map of what's underneath the surface. And the data that's stored in the block model is contributed by not only geologists, but engineers, geotech, all the technical services staff on a mine site populate that block model. So it's kind of like our digital twin of what's underneath the surface. So it's critical to understand where we're going and how to develop that mine. So in a typical block model, there's millions of blocks, and this is the data that we use to report to the stock market eventually. So all our reserve data is calculated from it. So it's really critical that we treat the block model with respect and integrity, because if the input is bad or incorrect, we're going to be reporting that, and it could be dangerous. So very critical piece of data. And within MinePlan 3D, we have a ton of ways of getting data into the block model. So we can interpolate our samples. So this can be our composite data that we have in the drill hole manager, or through third-party databases. We can code geometry, and this geometry can be what we capture through our reality capture technology that you've seen on the zone floor, so our current surfaces. But it can also be our design geometry. So what is our pit design? What are our domain designs that we're coming up with in geologic? All that input data gets coded into the block model. And then finally, we have a series of operations that we can do to calculate values. And these calculations are the insights that we bring as the technical knowledge base at the mine. So geologists, engineers, geotech, we all can contribute to estimating values that get stored in the block model and get used downstream. So it's really important that we continue to add to the model, because that extra data that we keep can be trained and improved on to get us a better outcome. So yeah, just as an example, so this is a block model from one of our client sites. So we're storing the geology, and within that geology, we get a feel for what the grade distribution is. And this grade distribution is helping us calculate a value. And from this value, we're determining what the ultimate pit is, and it gives us that life of mine. And then from there, in a shorter term horizon, we figure out where that material should be sent. So what stockpiles directly to the crusher, to the waste dump. That routing decision happens as a result of what's in the block model. So our key goal is to spin over models as quickly as we can so that we can get it out to our fleet management systems and our diggers, and we can determine the destination of that block. So a block size is probably, a typical size at grade control is probably the size of this room. It's a large area, but we want to make sure that we have as up-to-date, as accurate information as possible so that we can send this room to the appropriate destination. Because there's a big difference from sending it to a waste dump to a crusher. So you can either gain $500,000 or lose $500,000. So what we want to do is make that as accurate as possible and get it from the office out into the field in real time. So it's a journey that we want to undertake, but we're on the way with the Block Model Manager. Yeah, so why is there a need? So what is block model management? So I think, just in working, we've come across this problem because we see it on client sites. So typically, in the course of a year, if you just do the quick math, you can get a feel for how many block models are created. So we start out with our resource definition model, our long-term model. That gets branched and converted into strategic planning models, extra bit of input from the engineers to define the economics. And then ultimately, we have that grade control model. And grade control models branch again from those strategic planning models. And typically, we can produce a grade control model almost every day. So over the course of the year, you can easily end up with a few hundred models. And what we see, I guess, on the support and services side is that these models get zipped up, placed in a folder, and no one ever looks at them again. And if there are issues, they can ring us up, and we try to find the model. I remember an incident, this is in Australia, and I had a geologist call me up on the tech support line, and he changed all the copper values in the model to 3%. So the entire model was just one big red high-grade copper. And it was 2 days before he had to put a report out, a reserve report out. So in a panic, he rang me up. We went through, searched through all these folders, unzipped a bunch of files, tried to figure out which model was the most accurate. It took us probably like 3 hours, but at the end of it, we did recover exactly what he needed. So surely there's a better way of doing that, and surely, we can provide that for you. The other issues that we see are block model files are massive. So a typical block model could be 5 gigabytes. Up in Western Australia, where I'm from, those iron ore mines, it's like 20-kilometer stretches, 7 pits. Each of those models is 15 gigabytes. You have to bring them all into one data set to visualize, to manipulate. It's a lot of work. If those are grade controlled every day, you think about that, 100 gigabytes every day of new data being generated and stored somewhere. It becomes really important for us to consider what that means, because that storage is living on a server somewhere, which costs money to run. So we need to provide you with an efficient way of storing. Also, if we just go the approach of deleting or archiving, if we make a miscalculation or incorrect assumption, how do we then go back and find the correct version of that model that we want to use. So we don't want to be deleting or archiving data blindly. So that's the other problem that we wanted to solve with this. So this is available today. I think we released it in February. So the Block Model Manager can be launched within or outside of MinePlan. So what you'll see is you have a list of projects that you can maintain. You can import data from MinePlan or our competitor software, as well as CSV. So what it's doing is your desktop, it's synchronizing the version that you have of the model with a version in a central server. So in here, you can see that I've got 4 versions of this model, and at any point in time, I can roll back. So what I've done in this example is I'm just going to change the value of one block. So this block, I'm going to assign it to a different destination. It notifies me that the version that I have on my desktop is different to the version on the server. I can then publish this version with a note. And when it gets synchronized with the server, I get a green check mark telling me that it's synchronized. And that extra version gets recorded. So now I have a history of who made that change to the model, what they did to that model, and I can go back in time and bring back a version that has what I need in it. So it's a simple innovation, but it's really, beneficial, and it was kind of missing in the industry. What we've done in addition to this is provide an extra amount of metadata to support that version control so that you can assess how your model is growing over time. So we've moved the block model from a file-based structure that sits on a desktop or a central file location to a 3-tier client-server architecture where we have a block model service that can be deployed centrally, and your desktop users can communicate with it. So everyone's pulling from that same version of the model. Everyone's adding new versions to it, but we have that record of who is changing the model, what have they done to that model. And this opens up huge potential for us. So within the MinePlan space, I already showed you, we're the primary generators of data in the model. So we're interpolating values, we're coding values, we're calculating values. But typically, that model has been amongst the tech services group and not shared outside of it because it's pretty hard to show everyone that information. So what we want to do is make that data available to our ecosystem of solutions. And I guess being a part of Hexagon, we have a good testing bed for seeing how this can be used. So we can share data with our group in Drill and Blast, Mine Measure. We can share data with our fleet management system, and we can see the potential of that additional downstream work. So for Drill and Blast, they can measure the hardness as they're drilling, and that hardness can come back into the block model. And everyone can see that hardness change as we're drilling. For our fleet management system, as I'm saying, we want to get to the point where if something has changed in the field, I get results back, I should be able to change the allocation of this room to another destination, and that piece of equipment should send that block to the appropriate location. So that's what we're trying to do. So send our data to the field as quick as we can, get it back from the field as quick as we can to turn over the learning that we have in that block model. So it's not just within the Hexagon suite of solutions as well. We realize that, there's a lot of potential in business intelligence solutions and AI. So the API that we've developed was designed to pull the block model data into external programs. So you can hook it up to Power BI, you can hook it up to your Python library of scripts, and you can do your own calculations and your own unique IP that you may have that determines the best model for you. and bring it back in and visualize it in MinePlan 3D. So we want to be a part of your ecosystem of solutions, and we'll continue to develop that API based on your needs. So today, Gavin will walk us through how to put data into the model, and at the end of the session, I'll show you guys just what's available in that API in terms of new data. So the Block Model Manager provides valuable insights into our reserves and resources. And the reason that we're doing this is to make better quality decisions. And what we've done is not only change how we store the data, but the structure of that data as well. So yeah, you'll see that we've changed that footprint from 20 gigabytes to, in some instances, 200 megabytes, depending on the data that you have. So it's drastically changed how much data that we're using. And as a result of that, we get the performance of read and write times. Yeah, and as I was saying, we have this new API, and this new API is really allowing us to form new partnerships in the industry, and also with our customers, just really plug into their ecosystem and put their unique IP back into the block model. When we were designing these products, these three pillars that we had in mind. So management, so what tools do you need to efficiently manage the block model? What performance are you expecting out of that model? So how do we improve the storage structure? How do we get more people collaborating and make sense of that collaboration with a new architecture? And how do we support third-party models? Because we realize that you don't necessarily want to have everything in MinePlan. If one of our competitors is doing something that we don't, we still want to be very friendly in bringing that data in. But then, providing you with that extra bit of value. So you can bring in a data mine or Vulkan model, but you get the benefit of that API and the downstream connection to Power BI. So we want to be open in that way. And then ultimately, what new insights can we draw? So we've enhanced the metadata. So everything that was in the PCF or the project control file is still available in the new structure. But what else can we get in there? So how do we know who's changing the model? How do we know if we've run an interpolation, exactly what drill holes are in there? So all that additional data we want to have in our suite of metadata and APIs. And this is going to allow us to have that version-to-version comparison, that reconciliation, which ultimately improves that model. And then we get benefits from these three key areas as well. So in the management side, we're reducing that risk of data loss. So as I said, we're not storing things on a file in someone's desktop or on a shared folder. We're reducing that risk of someone deleting something or leaving the company with that critical piece of information. It's going to a central source where we're providing that extra bit of accountability and auditability. Performance as well. So we're creating a scalable solution. So there's a big focus within the entire Hexagon group on promoting collaboration from multiple parties. So we want to get to a space where out in the field, if you dig a block, as you're digging, that bucket information, that truck information gets stored back into the block model. And I guess as the technical services team, sometimes we're a bit intimidated by that. We don't want that model to be corrupted. But if we have an efficient way of doing that with that accountability, with that traceability, it makes more sense to do that. And that's what we're providing. So it's a scalable solution for everyone collaborating and adding data to that block model. And then ultimately, we can use that new data to inform new insights. And the insights not only improve that model, but lead to decisions that we're making in that daily operational sense as well. Yeah, so in terms of management, things that we considered were performance, the quality of that data, so ensuring that there's no data loss between versions. So even though we've drastically reduced the data footprint, we're not losing any data. We have all the data that you need. So that quality is there. That's security. So we want to ensure that, yeah, again, like only the appropriate people are writing to the model, and only the appropriate people are accessing that model. And then with the API, we consider the end users as well. So in the API, it's pretty straightforward. So if you've used a block model before, you understand the properties that we're storing in the metadata. So you should be able to get value from that instantly. It's also designed in a way that we can service multiple end users. So end users for us are traditionally geologists, engineers, but we've expanded that. So the other end user that we're considering are the data scientists that are being added to the mining team, the programmers that are being added to the mining team. So we have a different API path for those development personas, and they can add again to that solution suite that you guys have on site. So you're not relying on us to develop everything for you. You can develop your own solutions using this block model platform. And this is kind of an example of what we're seeing in terms of performance. So this is so in the blue, we have like a sample set of different models from different sites, different deposits. And in the green, we have that new storage format and what we get as a result in that. So in this right-hand side example, so we've gone from a 13 gig model. So this is probably one of our models in Western Australia. It's gone down to 900 megabytes. So that drastically reduces that footprint. So think of that in real terms over the course of a year. So you're saving on storage costs, you're saving on just the manual working of getting that data from one place to another. Like we're reducing that time, we're reducing that effort, we're reducing that physical space on a server. And yeah, I've spoken to a lot of data scientists in the last couple of years as well, and they've kind of proven this chart as well. So they spend most of their time cleaning and organizing and collecting data. So probably about 80% get a CSV from here, transform it, put it in this, and then you have an hour left in the day to actually get insights from it. So we want to take that effort and reduce it so that you have more time actually finding those patterns in that model. So yeah, we've definitely been listening to that data science audience. And to give you some tangible showcases of this. So firstly, this is kind of the metadata that we've set up. So this is what we have in terms of analytics in Power BI. This is one individual model. All my PCF data you can see on screen. And this is how that model has changed over time. So I can see an event timeline. So if I hover over those dots, I can see who's changed the model at what point. And this is available through Power BI, Tableau, whatever. So I have it on my mobile phone. Like if everyone wants to borrow my phone later, you can see it. So I can change the model and everyone can get access to that metadata to tell me how that model is growing. And the actual values themselves. So we can create a dashboard centered around the model. So this first one is focusing on grade on a bench, and this is intended for that operational audience. So how is my grade distributed on that bench? Tools like Power BI now have machine learning within them. So insights that geologists may have and spend hours trying to communicate to people are available within the tool itself, so we can have that accessible. This is another chart just showing how the geology varies on a bench. So putting this in the hands of an operation team, they know what material they need to handle. For our business audience, we can give them a breakdown of the value that's being generated on each bench. So where am I making money? Where am I losing money? And then again, from an operational point of view, where am I expecting that material to go to what destinations? expanding this again, that this API can be used and we can create new machine learning applications outside of MinePlan 3D. So this is an example using Python, the Jupyter library. Again, like I can visualize it outside of MinePlan 3D. So there's room for us to grow how we access that data. I can build more advanced statistics. So we have a pretty good statistics tool, but if we don't have everything that you need, again, you can go outside of our application suite to get your needs in there. And again, with third parties, so like we've opened up access to our block model data, and we've been experimenting with universities, with third-party companies, and they're coming up with solutions for us really quickly. So the rate that we can release new software is drastically increased as well. So we're really looking forward to hearing what your guys' needs are in our session on Thursday, and from there we can speak to the right people about delivering those solutions, maybe within Hexagon itself or through these partnerships. We just want to make sure that you're getting the most value out of how you build that model and how you use that model. Yeah, so thank you guys. Hopefully that was a good insight to where MinePlan 3D and MinePlan in general is going. And I look forward to interacting with everyone over the course of the next couple of days. So yeah, thanks for your attendance.